everyone, this is Maurizio, editor-in-chief of Power Electronics News and Embedded.com. I am at Electronica, showing in Munich, and today I have the pleasure to be here together with Roland Sperlich, Vice President and General Manager for Processor Products at Texas Instruments TI. Hi Roland, how's it going? Thanks for your time.
Thank you for welcoming me today. Yeah.
Thank you. So, Electronica, we are at Electronica. What's news from TI? What key technologies TI is showcasing in these days?
Yeah, it's certainly an exciting show. We've got some new products tied to power delivery. We're showing some of our innovations on GaN, some of our edge AI technology developments and enablements, industrial communications, some of our latest and greatest real-time MCUs, which are exciting, and I know we're going to hopefully discuss later today. And
for sure.
And then a lot of our exciting products for the automotive industry that support autonomous driving, driver monitoring, and things of this nature. Yeah.
So let's talk the new TI MCU for edge AI and real-time control. So the integration of an NPU in your series would facilitate faster, more accurate real-time decision making. So what impact would have in application, like I can mention arc fault, motor bearing fault detection for predictive maintenance.
Yeah.
So, but also let's analyze the specific challenges that engineers encountered when integrating AI-driven fault detection in real-time systems.
Sure. So, as you know, TI has been doing real-time control processors for over 25 years. With our C2000 family of devices. Real-time control is very important. It drives efficiency in the application where real-time controls are required, whether it be power delivery, motor control, any application where there's kind of a closed-loop system that requires fast processing. And so what we've added to the table is the ability to do edge AI processing in these real-time control microcontrollers. What does that mean? That means that when a motor is needing some help, we would rather that it come to stop more carefully, more gently, versus grinding to a halt. This will allow the motor to be serviced and brought back to operation more quickly. So using features from our AI engines that allow you to detect fault or other conditions, deteriorating conditions, allows us to accomplish that and do so more gracefully than before. Yeah.
So let's analyze your series F29H85. So this is built on TI's new 64-bit C29 digital signal processor core and offer an advanced architectures and so integrated different features in terms of safety in particular, right? Security and safety. So how does this architecture would enhance real-time control and computational capacity, and maybe what are advantages compared to traditional solutions, maybe talking in terms of safety and cybersecurity?
Yeah, so the C29 core brings a lot of interesting features to the table. First and foremost, we're obviously doubling the bit width, so that in itself is an increasing capacity for real-time signal processing. The devices also have gone from single core to multi-core architecture, so we're offering 3 cores, so that gives you even more real-time performance and processing. And then finally, we offer ultra-long instruction word, which allows you to execute more in parallel per cycle versus what you used to be able to do with our devices. So these are exponential improvements to the product offering, which is obviously exciting. And then let's not forget safety and cybersecurity, where we have our safety and security IP in the products to meet the latest and greatest standards that are obviously continuously evolving, but a very much necessity in the industry.
So let's focus on manufacturing. So how do you see the progress, the next advancements in terms of AGI, machine vision, transforming the role of centralized control in manufacturing? So what immediate advantages efficiency could bring on the table, could bring to smart factories?
I mean, one of the cleanest and clearest applications in the factory is the introduction of robotics.
Yes.
And with robots, obviously you have arms or motions, movements to help in the manufacturing process, and that requires real-time control, right? So, you moving your hand comes naturally to us, right? But to the robot, it's a little bit more effort,
Yes.
and so this is where our devices kind of come into play. Now, where do robots bring in value? They bring in a tremendous value in environments where we don't want people to be. If we're carrying heavy equipment or in environments where human safety could be at risk, the robots bring a lot of opportunities to aid in the manufacturing process and also keep humans out of harm's way, which is obviously a good thing. So to make the robot effectively execute more like a human, you bring the edge AI capabilities that we have, the real-time control capabilities to make decisions at that node, so that if there is some amount of human robot interactions, only good things happen, right? And so that's kind of the expectation and the challenge that TI is excited to offer to the market space.
Great. So, Roland, just the last question to conclude, just a final remark. So, in the future, looking at the future, so to the future, what do you believe specific advancement will drive sustainability, will drive efficient manufacturing in this regard? And so, how these innovation, these challenges, these advancements would improve, will address energy consumption?
Yeah, I mean, we've already seen the evolution of the automotive industry, and it's kind of taken on an even more accelerated path over the last decade. Being able to offer an electric vehicle offers environmental opportunities that
Yes.
we must consider. But part of that consideration is, will the car get to where it needs to go? And for it to travel not 300 miles but 400 miles, or if you want to convert to
Yes.
kilometers, the efficiency of the entire vehicle has to be at its highest. So when we talk about efficiencies, we can talk about the battery being charged, and that may be done through solar panels or wind, sustainable energies, all leveraging real-time control information to get the maximum efficiency. And you're driving that power down into the battery, and you need to charge the battery as efficiently as possible. Where percentage points of efficiency matter, real-time control matters, and that's what TI is helping to drive. So now you've got efficient batteries that are now driving efficient motors, because those are also enabled through real-time control microcontrollers. So the entire story ties very much together in terms of building a sustainable future for us, for our kids, for our grandkids, and it all ties back to driving higher levels of efficiency, so that so that we can make our planet run a little bit better.
Nice story, and it will be important to focus on sustainability and related climate change, for example.
Yes.
So, Roland, thanks a lot. I wish you a good day at Electronica.
Yeah.
Thanks a lot
Thank
for
you
your
very
time.
much. My pleasure.
Thank you.